Oh shit. So highlight it. Can I put that in my base bar at all? So there's the last line. So this is actually acceptance. What are you based on? That's the last one. Yeah. This is kind of not funny because what is the error, you know? Like, what is the error? CD execute, substitute. is this standard out? Maybe. I mean, standard error. The error is a static exception. Can only combine exponents of the same expression. Right. Guess you can type the errors. Print the errors. Runtime? No, it was a static assert. I can remove the static assert and make it runtime. I hope. Maybe. Okay, let's go git diff, git status. Let's go commit stuff first. Yeah, that's a lot of stuff, isn't it? Normally you have to look at everything because before you commit it. I just moved stuff, I guess, to new functions, new files. The sinus and the cosinus, and this is what is this? Generate. Oh, I can be removed actually. I'm not going to do this. Use this. Remove symbolic. Yeah. Yeah, I mean, I don't know. As long as my subconscious doesn't say that it is absolutely horrible, then I guess I'll just header test. Can't commit that. Is cos is exponentiation. What is this? Is less multiplication. I know. And I made a huge progress. It went so fast that I did a few interesting things already off stream before I realized that it was almost not fair to do it all off stream. Then I went on stream and then I changed immediately to boring stuff like checking if I can commit this. Now I've run into a compile error of more than 512 kilobytes of error. We can safely say that is the largest error that I ever had. So I finished this one off stream, so there is less, and the test suit of that. Hopefully that now more or less works. At least that was boring anyway. Everything looks the same, doesn't it? That was the last file. Okay, so we can add this. Git add. Not that one because it doesn't exist, but the rest. Git status. And I've got one. Add equals. Why the hell did I forget that one? Got. Git diff. Okay, wait a minute. Yeah. So now I've, instead of these formulas here, runtime formulas, I'm having compile time const expressions here, where the formulas are expressed as types. But somewhere something went wrong. Fix me. Maybe that's why I saw the plus space -8. Do I want to commit it? Guess I'll have to. I just have to remember that I did it. Maybe I'll grab my sources for fix me someday. Deleted stuff is always good. Man, I didn't commit for a while, it seems. There's more deleted stuff. Yeah, that'll fix it. Doesn't look like it. What is this? Yeah, mostly indentation changes, it seems. Auto fixes, I guess. Yeah, header fixes. Man, I changed that too much. Yeah, it's no fun. There's I feel like I'm going to commit it anyway, but there's so much. What the fuck is this? Oh, that. Oh, never mind. Yep, this is the test suite already. Most of the test suite was commented out. There's new stuff, new test suite. All of it work. No, I'll just commit it, right? I'll just commit it. Commit -A. VIP. Oops, why did I type make? Okay, Saiful, you have permanently lost my trust. And you're just a bot, or too crazy to allow here. So I'm gonna delete you. You can't even ban people, right? You just like that. So this error, where does it come from? Oh yeah, the idea was that now I'm going to edit stuff that, yeah, but all he talks about now is skaters and other amounts in dollars. So I maybe completely lost it. It's just getting annoying. Hello, Ensign. Okay, well, let me think. Yeah, I need to, I was going to remove the assert. Yeah, it is too much to even scroll over, so I did a make where I did to replace all those templates with something else. This one. And now we can see what it was about. It's about this assert here. And then the hope is that if I remove the assert, then it will compile, but maybe, you know, not even dive into this. If it asserts, might as well quit the whole thing. So if not is same, then we have a failure. But I want to compile. So let's return, I don't know, let's return 1. In that case, so it compiles. But also print it. Make it a runtime thing. I'll fill it in later. Yeah, unfortunately that did not, was not enough. Oh, wait, I can't print it. You can't print it in a concept expression. Arg, that's annoying. Yeah, these are constant expression stuffs, of course. It's a constant eval function even. Cannot do anything runtime. Okay, let's not do that then for now. See if then it compiles at least. Nope, does not compile. Auto in runtime deduces its power in earlier return statement. Initiation of a member function. What the hell is it talking about? Sometimes it returns a power and other times it returns a constant, and it doesn't want it. So apparently sometimes this is the same and then it does return a power, and other times it doesn't. So you can't just do something else. Basically means that can't do this at all. Okay, let's not do it at all then. But I'm still commenting out my static assert. Ta-da, it compiles. So this static assert fails. And then, how can I find out what exactly the types are? That, well, not exactly, but I wish I had a way to print types during compile time. Hi, Fatman. Fatman is back. So what you can do is if const expression failure, and then try to compile something that will give a compile error, and the error must print the type. And I thought I had that before, but can't be that hard. So kind of already does it, doesn't it? So this would word it fails, and now I want to compile something that errors out and prints it. Yeah, I had something like that before, but it didn't work. Okay, let's say let's say we do using something. Using foo is print type base. Hey, what about this? Bar. And then these don't have a bar. Isn't that not going to say that blah 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 has no bar? And then I kind of force it to tell me what that is. You just gonna do the wherever template type name t struct print type, nothing in it. That should work. Yeah, see, no type name bar in print ... Well, except now I want to know what ... is. But okay, we can grab for this string and then just print it. I'm gonna do just a grab for that part. Well, it isn't too bad. Fits almost on one page. No typing in. So base is this type. This type. This type. Yeah, I'm not happy. Oh wait, there's another one here. It's actually less than. That's the type. It's tiny type, man. You can do that, we can do that. I'm just going to find out what the problem is. Watch me do that. So this is this is base. Base is, and then I want to make it human readable. So I'm going to say sum of the product of a constant and the power of a symbol and a constant. And then the question is what to do now. What about, oops, oh that's even worse. All people login thump. Like that. Like that. Like that. Okay, now what happened? Insert, return. Do you see what I see? My editor has become crazy. It thinks it's an email or something. Undo. There's two of them, and then if I do insert enter, it makes another angle bracket. Crazy. But then sum is a what? This does not make any sense, does it? A sum needs two arguments. So this happened before. Okay, all the way back. I need a normal editor. I think I'm going to tell my editor that this is let me see, move to CPP. We don't have a toop now. Toop.cpp. I'm going to copy it again. Base is this type. Copy. Maybe I should write a script to do what I am about to do manually, because I probably have to do it a lot of times. But yeah. Sorry. Product of a that doesn't make. Oh wait, it's a power. Yeah. Okay. Okay, this works. It's the sum of a product with this another sum. Constant power symbol constant to basically I want a new line after product and after power and after sum, and everything that takes an argument except constant or symbol. Product, not a sum. Oops. Design is lots of nested multiplications. and so on. It's even, I don't think it even helps. It's just too big anyway. Shit. So I write a C++ program that reads in this and then prints out this form. I think I have to do that. Nah. Why not read from standard in? Let's read from standard in. While, yeah, well, there's reading complete lines. First, it's just one line. Let's read everything in one line. Input. I have to treat it as binary, I think. Otherwise, it's just going to read until the first space. How do you do that? I don't know. I never do human I/O. No, it's already here. Unless I fucked it up. Now it's already here. into the first place. Anyone? Does anyone know this? Hello, C++ coders. How do I read a complete file? Complete text file with basis into a single standard string. But then again, why would I do that? I might as well process it immediately. Using RD buffer. Nah. What I had in mind was use binary stuff. Okay, I don't really care, I guess, because I'll just read it in parts. So now everything was space separated, but okay. Now I want to read it actually a word. I want to read one word. It's not a string. You really have to read it character by character just to detect it. This. No, AI is not useful. Let's just Google it. Yeah, this is space separated. I don't want it to be space separated, really. It must be separated by anything that isn't a character. Alright, split. I have something in my utils that I used to use for that. I already forgot about that. I think it's in utils. I could have started reading at the S, of course. That would theoretically have been possible. Because I already had the clue that it was called split. Does this thing work? How does this thing work? Call found token is v token for every. called found token, which is apparently a lambda, is string view token for every token. Empty tokens exist too. Found token is called at least once, as often as there are delimiters plus one. But this thing has only a single delimiter. And this one is doing what? Array. Then you need to know in advance how many separators there are. Yep, okay. So we can call split, util split, string view, comma delimiter. And then use the lambda to append it to a vector or something. Let's try that. And it's including AI alert. Don't tell me I have to use the full-blown stuff. That always sucks. I just copy this. How about I just copy it? So now I'm going to call split. With a string view, you can create a string view from a string. And then as delimiter, I use that, for example. And then our lambda is going to call, nobody knows. What was it? Probably a string view. String view, probably a constant, I don't know. Let's see what this gives. No, it seems to work. So if you have this as input, you get exponentiation and then sine and then sum and then product and then constant and then -1, comma. So the separators themselves are not shown. But this is hardly useful because I want to also know how to have multiple delimiters really. Wait a minute, I did this already. I'm sure I did this already. I think I called it tokenizer or something. So I have to look at and probably still utils. Something with token. Token. Let me see. Oh, something like here. Reverse signals. Template string literal. That's also an interesting. Yeah, I don't see it here. not here. How can it not be here? I wrote something that you just can just tokenize a string. Come on. And I did not put it in utils. So where is it? Where is it? Let's go to my largest project. This is still my largest project. Maybe this thing has its. Don't see it. And there's all external stuff. It's getting very much in the way. Talk, no. External, no, thank you. External, Tracy. What are we doing here? This. Really? Okay, what do we have here? Examples. Solve a task. Probably not. This is suspicious. Definitely something with tokens. Util split. Don't talk about this, talking about tokens. Spin. Now we get again external. Nothing. No. Yeah, forget about tokenizer. I'll use split. So we read everything separated by spaces. I think I want to keep the spaces maybe also. I don't think I get spaces. Every space is just one space. So if I add the space to the input, then I kind of have all these the same input again, I think. For example, if I just print all the output then I just get the same thing back as was in troop. Yep, I mean that's the same thing, including all my spaces. Next, I can then split that input by less than, why not? And then for each thing, let's just put everything in a vector. I don't really want to split it into. Really? I think words and characters. That's my first desire. So make a vector of strings called tokens. Yeah, let's call this 1, and this 2, and they already call this 1, and then print 2. Let's see how, if it compiles, and if it compiles what it does. It doesn't of course need a header or a vector. Maximum range. And then we can do this thing again, and now we get lots of spaces. For some reason I lost all my less than and larger than things, which is not a problem, but why are there so many empty lines? That is the question. Oh, it's for the empty things. We have a lot of less thans all on a row. So it calls split whenever we have something. So I think that, yeah, I have to basically let's make a new string test, and then if I get here, I want to add test. Sorry, I want to add to test the token that we don't get, and then here the other token that we don't get, but also probably SV2 itself. I think the token comes after it. I'm not sure though. Let's print test at the end. This is not captured. Capture it. My reference, obviously. That works. It even works. How is that possible? No, it does not look like it is what it used to be. So, now yeah, first guess without even looking at it is that I added this at the wrong side of SV2. Yeah, that looks a lot better, but still not good. Definitely, no, does not even look better. Get lots of this stuff. No, it's not good. Definitely not good. So I get this as input, while we have this. Okay, so we get the sum must become before the less than. No, I have it before that. Printing stuff too quickly, in fact. Adding it too quickly. This must be added at the end, and then here it must also added at the end. I think now we get a lot closer. Really. Oh, nope, still not. But now I get some, and then it closes it. Why? Okay, what's going on here? Why is that less than here? Stupid split. Who wrote it? Hold on that, and then that, and then okay. Okay. Yeah, so we have to treat it like separators. Really? Now it looks good. So now I can continue this with anything else that we want to split at. Splitting it at those two now. Also want to split it at commas and spaces. Where do the spaces exist actually? I don't think I need any spaces except after every comma. There's only spaces after commas. So I don't really need spaces. Just detect the commas. So I'm going to do another split instead of this. We do character cons pointer. Separator 3 is empty. And then split. And then inside the split, wait, let's split this SV2, comma, comma, and then actually that 3. Okay. Maybe I'm not convinced that this needs to be indented 4 spaces anymore. And then here we have the same thing, 2 spaces. Test plus is separator 3. Standard out, right SV3. And sep3 is comma. It's gewoon je comma space. Then that should still work. Something didn't work. Very interesting. All the separators are gone to one side. What the hell? Man. Oh, I'm printing this. Yep, total asshole I am. Test plus SV3. Much better. Let's also get rid of this. It's totally not necessary anymore. Now, what other things do we have to split on? Tokens. No, how about you just write it? We have the numbers actually. Negative numbers. But all the digits are parts of a constant or a symbol. Yep. They should be. They definitely should be. So, what I would rather do is well, I can just treat them as tokens as well. I think the -8 is now a token. So between that and that, right? 2 separators. That's good enough. Good enough. Now look at true C++ coder. I'll write a class called decoder. And then we'll make a decoder thing here instead of test maybe. Instead of test. Don't need that here. And then here it kind of depends on if separator is set or not. So that's actually all. So I want to just know if it is the first one, so let's call sep1 a boolean called first one, which is true. Sep1. So then here we set sep1, or actually first one, to false. And then here we can do if not first, then added decoder let's call it open, angle bracket open. And then the same here, so let's call this bool first 2 is true because this is going to be the first one. And then after that it is false. First 2 is false. And then here I can do if not first 2, decoder close. Then we had a closing thing. And then here's the third one, bool first 3 is true. Separator is set here. I can, in other words, first 3 is false. And here we add it, so I can do if not first 3, decoder dot comma. Yeah, that's not needed. And then here we have a token. So let's say decoder add sv3 as token. Standard string test. It's back. It's back. Void. And then open, close, comma, add. Add token. No, then in order to test it, I'm going to add it again, plus that, test plus comma space, and test plus is token. And then in the end we print, of course, decoder test, which then must return my test, because it's private and stuff. Let's add an accessor. So that's string const reference test const return test. No, let's make it test underscore then. Don't want to have the same name as my function. That should compile. It does compile. Yeah, as if you didn't do anything. That is a good thing. So now we have a class where all my events are happening. And now I have to decode, well, depth. I'm not going to have a test anymore. Int depth. Depth is 0. Open plus depth. Minus depth. I didn't plan any further than this. What I wanted to do was print everything, actually. Might as well print it instead of pen it to a string. So, instead of any, print everything. Now, apart from taking into account what the depth is, you just print it directly, so there's no necessary. Yep. Okay, no new line, but for the rest, almost good. Same thing. Yeah. So now we do the following. Well, I guess every time I see a token, every time I see this, then the previous token is the one that is being opened. So I could do the following thing. Well, let's say we have a huge array with stuff in it. Huge being, well, how many? I don't know, 200 must be enough. And then, how shall I call my array? A, of course, yeah, A, well, yeah. I'll just store the token in it. It's a string view. Shall I store string views in my array? So I could do is a depth is token. And then here we have access to the last token, namely, well, before we increase depth. So if there must have been something in front of it, but anyway, it's just like literally that thing. If that equals constant, or it equals symbol, now we want to change the mode to not printing any new lines. So let's say no new line mode, basically. Well, mode is no new line. Nah. Let's make it simpler. Print new lines. It's false. I need a boolean called print new lines, which starts with true. But yeah, on the other hand, then if I find the closing one, but actually in a constant, it just does no nesting, is there? No. So to keep it easy, as soon as I see that and no new lines is false, then I know that we are at the end of the constant or the symbol. So then I'll do print new lines is true again. Yeah, but in both cases we're done. So basically everything else is... Oh, wait a minute, I still need to do the minus depth. Unless I do not plus depth here, but I guess it doesn't really matter. So let's do the plus depth anyway. So if you see this and it is not a consort symbol, then I want to print also a new line. Duh. Yeah, not just a new line, we also want to print an indentation equal to the depth. I'm going to be extremely lazy. And it's for y is 0, y is less than depth. Print 2 spaces for each depth. Now, shall we see what this does? Actually doing something with the spaces as well. Oh yeah, of course. Escape include array. Trying. Sum, and then a new line, and then product without an indentation. Da 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 da. Why is that? And the constant is not printing anything. Symbols are printed like that, constants are printed like that. That works. Everything else, I get a new line after the opening thing. The sign of new line symbol, no new line. Well, the closing thing is not handled. But yeah, looks good. Looks like what I intended, except here. There's a missing indentation. It's kind of weird. I guess the depth is also kept track of. Track. Okay. Yeah, I have to increment depth before doing this. Or we can just do less than or equal depth. Now, the thing that after F3 comma I want to print a new line as well, except when the comma is a part of the constant. Thus, something like that. No, print I forgot to not print it after. Where our inside thing comes inside, yeah. So basically, if not print new lines, then don't do that. Else do it. Instead, we just print on my comma with the space. Product constant comma. We have an indentation here, which I did not want. Why did that happen? And here indentation is not enough. Something is totally wrong with it. Chip. What? Much better. Sum, product, constant, power, symbol, constant. Sum, product, sum. This is the sum of a product in a sum, and the sum is a product in the sum. So after this we have to be finished. No, apparently. How do I get my closing things correctly? What I do want is to print that one with the correct indentation there. Meaning indentation has to be one less. Then I want to print a new line. I want to print a new line before that thing. Unless it's part of a constant. So decrement the depth and then print the new line in the indentation and then print the larger one. Decrement the depth. Print new line and indentation. Actually the same as this one. Wait a minute, before that. To just print a new line and then indentation and then print less than. Yep, now this one lines up with that. That one lines up with that. Sum of a product in the sum of a product in the sum of a multiplication of a constant with a multiplication of a symbol and a multiplication of another symbol and multiplication of a sign and so on. How difficult is my sign actually? I think I have only 2 signs, or the most complex one is this one. Might as well print all of that in one line. So I think I should turn off new lines while inside the sign, which is then slightly more complex than I thought, because I thought that it would not have any nested stuff, and then suddenly I do. I don't know where that went wrong. If I do have nested stuff. Oh yeah, of course. We have to nest the number of times that we encounter this. I'm encountering constants and symbols inside my sign. So let's make this an integer that starts at 0, which means true. Print no new lines, then print new lines. Print no new lines is now incremented by 1, making it true. And then here we have if print no new lines, which then just tests whatever, you know. And here I say true, well that means nay, minus then, right? Print no new lines, so that could become 0 and then it is true again. Well, then it's false, not no new lines, means print new lines again. Yeah, now I think now we can nest it, and it should be nested with the sinus. Uh-oh, that did not work, apparently. Why? Well, because the sum actually did work, but the sum just prints a new line. I don't want it. Huh? What? Oh, it's over. Oh, wait a minute. Yeah. The token is over. Wait a minute. The token is overridden, of course. So then I see this one and I do the test, and then test is not true. No, it makes no sense. Good top. So this one works, apparently. The sign of a symbol of 4. Sign of a symbol of 5. But a sum inside a sign is fucking things up. And we get the double depth. The sum of a product and a symbol. I guess that belongs to the sum now. Yeah, it is not what I wanted. Printing new lines after, pretty sure after opening here and closing both. I think I'm just ignoring my boolean, my pseudo boolean. Yeah, that's what that's the problem. So every time I print a new line, what is that? New backslash in. We have to test, of course. So if you do not want to print a new line, then already printed this. We're kind of done then, right? So this is just if print no new lines, as in not no new lines. Print a new line when there's a not set. That's what's missing, I think. Everywhere, basically. But this is also printing that thing, damn it. A minute, I need if not print no new lines, print a new line and the indentation. And then you see that if you swap this and put that one at the end, you might as well put it over there. So you can remove this one. Remove this one, this, and then this, and then of course make it like that. Not that it matters, but hey, yeah, we could do that if we wanted. What about this one? That one is way more complex because this also has a space. Cannot do the same trick. So here I'm gonna do, if not print no new lines, do your thing. And otherwise we still have to do something, namely print this, comma, with space. Other new lines are non-existent. And still it didn't work. Or did it? The sign of the sum of the product of a constant with the symbol. I think this sum here is belonging to that. So it seems I'm still printing new lines after a comma. Well, I don't want to. Comma, comma, comma. Well, I shouldn't. Ah, right, I see it. Yeah, I'm only adding it for constant symbol in sign. And then not printing new lines, even if I see others. But actually it's counting the number of opening things. So either I print new lines or I increment this. So I don't print a new line and it still has to be incremented. Again, else. Because it didn't print a new line. And then upon the close, it's just counting down until, for every close. That still works. The comma is also completely separated from it. I think that fixed the book. Better. So now I have a sign of that stuff. And we have the constant, what belongs to the exponentiation. No, can work with this one. Okay, so that's the base. How do I call it? Print type. Yep, apparently. Two. Apparently that type is not equal to this type. And then we can only, oh, that's definitely not the same type. That is definitely not the same. Wait a minute. I didn't see this before. Never mind. I'll just, oh, I'm stupid again. Wait a minute. Okay, so, well, I did just the make, right? I have to do, you have to do this. You know, it's almost nothing. Oh, now I get again too. So I'm going to assume that this is the type. Looks like about the same size now. Yep. And then we can do this one, but it's definitely not base now. It's already other. Let's call it base 2. vi base 2 dot text. This is the other one. And they are not the same. They are 10 characters different. Diff. So it says, hey, I expected it to be the same, but it isn't. Well, we'll know now what is different. The constant is different. All the constants are different. Ah, brilliant. Absolutely brilliant. I could have thought of that myself. Yeah. Yep. Not that I understand the solution, but this is very nice. Because I'm treating every constant the same. So it's completely correct in one sense. And that we end up here because, yeah, according to my less than, these types are the same. I just can't use a standard same as because that doesn't treat constants the same. Definitely cannot use that anymore. Nope. But now the question is how to combine these two things then. If the constants are different. Maybe they should have treated not the same. That part is also still missing, I have to admit. So the idea is that we are adding stuff like a plus b, yeah, and that should stay the way it is because a and b are different things. But if you do a times a, and I don't want to keep it as a sum, I want to write that as 2a. And I could recognize that a equals a because it just equals a, right? However, if I have a plus 3a, then I still need to recognize that a and 3a are basically the same thing, and then turn that into, well, 4a, or let's say 5a if this one is a 2. Yep. And I don't know what happens. 2. No, it doesn't want me to type 2. But you get a picture. So 2a plus 3a must be considered equal, and then we can combine them. Well, there's a lot of stuff missing. One of the things that is missing is that I do not even combine them. So maybe I should not work on the quadratic Bezier curve length thing yet, but just add to my test suite this little test. Then I get that part working. Which then will run into the exact same problem, I think. The same assert, except with smaller types. How late is it? Okay, so test suite. You go to symbolic, and we add to the test suite. Let's start with the products. Let's start it as simple as possible. I'm going to have, let's say, I'm going to force the types with using argument 1 is symbol 0. And the argument 2 is then the product of the constant 2 with symbol 0. If you add these two, then you should get 3 times symbol 0. So let's say auto foo is at arg1, arg2 instance. And I can print it. See what that becomes. And it prints 3 times a. So that worked. How the hell did that work? Well, I'm kind of surprised that it already worked. Now, obviously, let's make a test a little bit harder. 3/7. That would be 1 plus 3/7. So that is 10/7, right? That would be even nicer if then. Is that even possible? I don't know. Let's just 10/7 is good enough for me. 10/7 a. So that works. Okay, and what if this one is also a product of the symbol? Let's say this is a 4/7. I want to divide it by 2. Let's make this 14th and 2. So this is, if you add these two, and you get 4/14 plus 3/14 is 7/14 is a half. That's what the result should be. A half. So it seems that this kind of works for products. But why? But why? No, not what why. No, kind of though. So the add t here, what does that do? Let me follow it. Add t is defined as the type of add, and add is defined as this, or that, or lots of other stuff. This is a sum, this is a sum, this is a sum, this is two constants, and then we had it, I think. So utils. So it's probably the first one then here. The default on E1 nor E2 is a sum, okay. So we get here, and then it says if E1 is less than E2, sum less. And it isn't, because they only differ by a constant. So in the end we should get here add equals 4 still the same type, so this is still the product of a constant times some symbol, and the other one as well, which is defined as the type of add equals, and there's only one of that. So we get here, and then we get the constant. Though this is what deals with it. We get simply the constant factor of both and a non-constant factor, but a non-constant factor is then indeed the same thing, and that is even tested with is same. And then we are multiplying. The constant factor is simply the addition of the two factors. And we multiply again that times the non-constant factor 1, or the product, or whatever. So there's no surprise that this works. But why did the other case fail then? Probably because, wasn't even this assert? Probably it was this assert, right? So that means that the non-constant factor was differing in a constant somewhere. Let's first test it with multiplication. So product works, and now I think the multiplication should also work, because there's not really a difference. Product is one way to multiply stuff. We have also multiplication. The multiplication is not allowed to be the same as a product. I hope this doesn't even compile, because it should tell me to use a product in this case. Let me test that. Damn it, it just compiles. What the that is really weird, man. Why? Still working. It's not good. Multiplication. Yeah, I'm not testing it here. It's kind of, maybe it's not possible to test it, or I just removed it at some point. I think there's the problem, basically I think a problem with C++. I would like to add a requirements here, like requires that E2 is a non-product type, but Actually, either way, or E1 or E2 cannot be a product type. Then it's okay. But whatever requires you add here, you also have to use for whenever you forward declare multiplication. So I have class multiplication forward declared. So here we would do something like not is I don't know, is symbol v, and a lot of other stuff. You know, just to restrict it that it cannot be take the same arguments as a product. But then I have to do that as well at the forward declaration everywhere. Everywhere, but hopefully not too much. Nope, not too much. So here, I have to add the same requires here. And I can't because at this point there is no is symbol and is constant and is whatever. That just doesn't exist yet. You say, well, include the headers then. You know, but yeah, I can't do that because then you get circular header dependencies because the test that I need to add here. Wait a minute, I split it up in so many files that is actually now possible. Maybe I was going to say that this header depends on. It's not true. Well, that's. Let's just say is symbol as an example. All these is whatevers, they were all in one header file, and that was maybe the problem. See, this thing doesn't depend on anything. I can just include it. Haha. Aha. Okay, let's have another look at what I really need. What I need is product level type or something close to it. Exactly. One non-product level type, which is defined in is less multiplication, which includes everything. Yeah, that's not gonna work. But I could put these things in their own header. So what was it? Product level. Where's it defined? At the bloody top. Concept non-product level. No, I need to be able to test if it is a product level. Product level. Product level is defined somewhere else, probably. I need that, not this. You need concept product level type. Which is defined here. Oh, I could include that. I think it should not depend on that should not depend on multiplication. Let's put it that way. It should not. This power.h is constant, is symbol. I'm gonna need all of those things. Yeah, no problem whatsoever. Maha, maha, ha, ha. So what do we say? Is product defines it? Product level type. Let's try it. So the for declaration was here. And what happens if I just include is product.h? Does it still compile? Yeah, well, I get the same error as before. I think it compiles. Wait a minute, yeah, I should try to compile the test suite then. Nothing to do. Well, I just compile that, I suppose. So we can do requires that not is product level type E1 or not product level type E2. Both are okay. And we can add that there too. And now it says constraints not satisfied for class multiplication because not product level type constant evaluated to false and a non-product level symbol evaluated to false. In other words, I should have used product. And likewise, I think I should make more restrictions. Now I'm at it. It is also not allowed that the multiplication is used for E1. That's kind of hard to test though, because that's defined below it, using multiplication. Can hardly for declare multiplication, demanding that the first argument is not a multiplication when you need to do a test that uses the class itself, which you didn't for declare yet. Can't for declare stuff like that. That's stupid, but okay, this is better than nothing. So probably do the same thing for product, if not already done. Let me have a look at what product has for requirements. Our product has a lot of requirements. It requires that E1 is a constant, but not 0 or 1. Or it is a symbol, or it is a power of a symbol. And E2 must be a symbol or a power of a symbol, or a product. So the first one cannot be a product, and wait a minute, how did I do that? Oh, this is weird. This is exactly what I just said was not possible. Now I'm having for the real class, I'm having a requirement that includes that E2 cannot be a product. But this is of course using product, therefore using a for declaration. Are you telling me now that a for declaration does not need requirement? Requires? What? Or do I not have a for declaration? Well, that seems extremely unlikely. No, of course it does. Sorry, I need it for this. So isProduct v is defined as isProduct false. Oh yeah, I can define it like that, and then later define the specializations of isProduct. But that's done immediately here, and there it is. Oh, that's how it works. Oh, nasty. Yeah. See the isProduct v is just the value of isProduct struct, which is defined here as simply not depending on product at all. So we can define this before product is known, and then we can for declare product using the isProduct, which is not depending on product itself, and then specialize isProduct using the just for declared product as a true type, so that now afterwards isProduct is going to be true if you try to pass a product as a template argument. So it is possible. Yep. No, I want to do that for multiplication as well. So I need to define is multiplication before we do the for declaration. Of multiplication itself. That is the trick. Ping, just put that above it. And now I can use it here. So we demand that, but we also demand that E1 is not is multiplication E1. I think that's going to screw me up with the test suite. I did violate all those things a lot during the test suite. Or not, because it's still complaining about this one. That's the first one. Okay, let's fix this one. Okay, so we're not allowed to use symbols here. Let's use the sign of the symbol. Just as long as it's typed that it compares to completely equal with itself. So this should now work, right? And then that prints half this sign of A. Yep, that works. Pretty cool. Okay, but so the assert that I got was for something else, and I have a feeling what it was. I might have, you know, if we do something like, so if I compare these two, if I less compare these two, then it's going to say, okay, a constant is a constant. I don't care what the value is of constant. And it just compares these two. But at the moment, it compares that at the same time, as if this doesn't even exist. And that can go wrong. That is, if, for example, well, here's another restriction. This, if this is a constant, then this should never be a product that starts with a constant. Because then that constant should have been combined with this constant. And if it is a multiplication, actually, if it is a multiplication that starts with a symbol, then it should not have a product as the second argument. Well, never anyway. Wait a minute, this one, oh, sorry, multiplication, this one must be smaller than that one. Which means that if this is a product level type, then that must be a product level type. Which is not allowed. Is there a way to circumvent that? I don't think so. This is no longer allowed to be a multiplication now. So if it's a product, then this should be a non-product. Yeah. I think everything kind of works mysteriously. Okay, anyway, how to get an assertion to fail. I don't want to use something that is illegal, but just not tested for. So So I can't use a product here. That starts with a constant. And I think that exponentiations actually should be detected. I make this an expo. Wait a minute, has all exponentiation also not allowed of a symbol? It must be a power then. Let's make an exponentiation of the sign to the constant 2. Exponentiation of that same sign with the same constant first. Now they are exactly the same, of course, so now should not have a problem whatsoever. And just get a half that again. Or I made a typo. I made 2 typos. Yep, that's a half sine squared, sine a squared. But now let's say I change this to the power 3. And then of course you can no longer combine them. But if you say, well, every constant is the same, so that works. It's no longer combining them, so they are considered different. But I think that's because exponentiations are not treated like that, are they? They are explicitly compared all the time, I think. Let's have a look at that to be sure. Less sum. So I have an exponent anywhere from the top. We have an exponent somewhere that is power exponent. It's a power, okay. So a power on one side and E2 is not allowed to be a power. Exponent of 1, yeah, C, no C. Oh, actually perfect C, yeah. So I'm using this, but I'm passing false. False being constants are no longer compared equal. This is how exponents already are compared. And this is for a power and a power. So the only other case really is for exponent and exponent somewhere. Should find that as well somewhere. This is not compared. It's always comparing exponents directly, right? Exponentiation. Yep, here. Exponents are compared with false already, so that works. But that's kind of like the only place I think where I pass false. This constant and a constant. Okay, 2 constants are compared literally if you compare 2 constants. And this is exponent and an exponent. That's it. Okay, that means that if I do no, I can't do that. Never mind, okay. So I think I need something that is Ah, right. I'm not doing exponentiation of constants, I think. No, because it's not possible. Let's say we do it to, well, if it's squared would be possible. So I do it to the power half. Then, and then I make this one a product. I make it a pure product, it's not allowed again for the exponentiation. So this sign must be involved. I can make it a product of that sign with a constant. And then let's say the constant is just 2 initially. Let's pick here where there's the exact same type for start. No, the types are the same, so this should be again no problem. Just a half times whatever. Constraints not satisfied for class product. Oh yeah, again not allowed. I'm not allowed to use a product with a sign, of course. Sorry. I'm not allowed to use a product at all inside an exponentiation. Actually, let's make this a multiplication. But this is again just we are combining it to a half times whatever it was. Wait a minute, what happened here? Oh yeah, I said 2 times. So we have 2 times the sine of a to the power half. That's the square root of a half is not rational, so I cannot store that as a constant, which are only rational. Sorry, only rationals. And but the sum has been combining 2 terms because it was now 3/7 plus 4/14 or something like that. Times that. Let's see. 2/7 times that thing plus 3/14, and that became then a half. And now I hope that now I found the problem. If I make this constant a 3, now you can no longer do that, I think. Yes, it did assert. So it failed due to requirement is constant expected the same non-constant type. So I think I reproduce it now. It detects that the type is not exactly the same, which means that you just simply cannot combine them. But it did think that they were the same because it's comparing it as follows. It says, okay, multiplication is this type less than this type? But this is a multiplication of a constant, therefore ignore the constant. So I'm just going to compare if this is less than that. And that then is an exponentiation of something with the same exponent, therefore it's going to compare this with that. And then it's going to compare this with that and then say it's equal. Which is bullshit. And then I have to think long and deep and hard to understand when exactly I can ignore those constants. I think not at all, right? As soon as you ignore the first ones, can I then, is that even possible to ever ignore any other constants? I mean, they would have to be combined as well. If it's an exponentiation, never, of course, never. Well, that maybe certain optimizations are possible, but in general. In general, I don't want to do that, I think. So maybe what I should do is stop comparing constants as being equal. As soon as I do one skip. As soon as you do one skip of a constant, then everything must be the same down to the constant. Exactly the same. So then it would compare this with that, but consider these two constants different. And therefore say that this expression is less than that one. Well, ordered on the left anyway. It is definitely true, and this is an exponentiation of. But what if I remove the exponentiation? Then it's not really the case, except that then I have a multiplication of a constant with a multiplication starts with a constant, which should never happen in the first place. I wonder if it even happens if I do the sign of a constant plus something. So I put a little less complex on this. So no exponentiation. Let's do the sum. No, let's do the sign of a sum. The sign of a sum of a constant. And the symbol. So we start with the same thing, so that is just going to be working again. A half times the sine of a half plus a. And then I'm going to change the constant inside the one of the signs with something else, which of course cannot be combined anymore. Yep, get the same assertion. Okay, but now the question is it possible to construct a type here where indeed I can, or should rather, consider the symbols, the constants, I mean the same, because I can combine them. Only when it is a product again. Only when it is a. So we say we have 2 times a plus 3b. Sorry, 2 times also a, but that works. But now I want to have a to have again another constant that I can still combine. I could, for example, think about, let's say, 2 times b plus 2 times c, if that is legal, because of the 2 constants, but I think so. And then here, let's say 5 times b plus 5 times b, c, I mean. That can be combined. That would be 4b plus 8b. and now this is just b plus c times a constant. Which constant is that? Uh, 4 plus 3 times 5 is 15. But that would be 19 times b plus c. But yeah, I think this should be illegal. That should be forced. It should have a canonical form of 4 times b plus c. Shouldn't it? Or maybe 4 times b plus 4 times c. If this would be converted to the canonical form 4 times a, and it has to be. It's impossible that this exists. And then I add that, which then would be 15 times b plus 15 times c. Then that's going to be sorted, and then you get the 4 times b and the 15 times b next to each other, and then it's combined into 19b. So in the end it's going to be 19 times b plus 19 times c. Definitely. So I can't even make this type, I think. Can't make it. I can enforce it here, and then maybe there's no requirement that stops me from doing that. And then I can get this to fail. But in reality, this would never occur. I would rather have it do that I cannot force it. It should not accept any type if I try to make it like this. That is illegal. So what is the main problem about this one? Let's say I try to make it. That would be you can do test S. And then I do. I have to. Well, I should have to. 2 times b. Let's use x. Plus 2 times c. 2 times y. I bet that becomes 4 times x plus 4 times y. Yep. So that's already combining these two multiplications. And then if you try to do the above, like a plus 5, 3, I don't know, I don't have those constants, I think. 3, constant 3 like that, times constant 5 times y plus constant, I said 5 times x 19. So you just convert it to this type. The sum of the product of 19 with x and the product of 19 times y. It's literally this. Already. Even though I can probably force these types, like it's not even clear. What's the sum? Okay, so there must be a multiplication, and you take just the same thing there. So 2 times 2 times the sum of the product and another product of the constant 2 and the symbol. No, just should use symbol 0. And they are again constant 2 and symbol 1. And then here we do the exact same thing, except we're using 3 and 5. So 3 here. Now we try to add those, but these types are illegal, so they should never happen in the first place. But okay, let's see what happens. It's hopefully telling me that I can't make those types, but fail to your requirement is constant multiplication. What does he say? Expected to have non-constant type. The same non-constant type. So okay, it fails. Well, duh. But it fails because I'm still considering constants the same. And we can fix that probably. I have the feeling that it just change that. So as soon as I skip one constant, I must change the constants compare equal to false. Yeah, find that back. I think I have 2 of those. Either something that starts with a constant, or something that tests that it is a constant. For example, in this case, we have multiplication of a constant times E2 with anything else is true if E3 is not a multiplication, which I think is just avoiding ambiguity, and E2 is less than E3. So this is completely ignoring the constant, completely, right? It just says, well, okay, if you want to multiply it with a constant, then I'm just going to compare E2 less than E3. However, now we did skip a constant. So at this point, I want to tell it that from now on, you can no longer ignore constants. So we are going to do the same thing as we did there, which means I'm using is less sum value, and then I can pass false. And that also means that this particular specialization is no longer allowed because, well, it takes a constant. So I think I just should remove this and demand that that is still true. So we go from true to false. Well, this is defining is less sum with true, and then we call it less sum with false. You can only do it once. And then here I have one that is again, we have a multiplication that starts with a constant, and we ignore the constant by calling this. Therefore, it must be the same thing, right? This must be non-existent. And this must be still true. And then we're going to pass false here. Okay, look for others. Did I just jump to the top? Apparently, this is the only constant that I have. Well, there is definitely more than that. I think I'm testing stuff with is constant. So for example here, multiplication E1, where E1 is a constant. So that's a bit dubious then. I mean, maybe I should split it up like that. This one is a difficult one anyway. 2 multiplications. I think I probably should better, instead of looking for constants, I should look for multiplications and products. Those are the only two where I possibly ignore a constant. So yeah, for example, in this case, E2 is not allowed to be a constant. So nothing is skipped here. And here, E2 is not a constant. And here, E1 is not a constant. That's how we should do it. And here, E1 is not a constant. So it's also not skipping anything. Here it is a constant, but I already did this one. And this one. And then this is the special problem here with the 2 multiplications. And then we jump to the top. This is the only one left. And the other one is the product. Let me look at that first then. The product E2. E2 is not allowed to be a constant. Or, So apparently it is allowed to be a constant. I'm sorry, but I'm going to look at the multiplications again. Of course, now I'm already sure that the other ones don't have an or. Okay. Yeah. I'm adapting to add another specialization for where the product starts as a constant, or just add the value of this thing to the requirement. The biggest problem there is that also this one must depend on all of that kind of, I don't know, I like that. I don't know. Let's do what I did before, as in it's just not allowed to be a constant at all. If it's not a constant, then the symbol is always less. So I could just remove this part. And then we do this one again. But this time we want to have the product definitely start with a constant. I'm lame. I'm going to make this a 2. And then this one doesn't require anything. Yeah, well, of course it does. That requires that one then. Where now we are actually wanting to compare with E2. So if this is a constant of product is a product times E2, then the symbol must be less than E2. That's yeah. Plus, of course, we have to switch again. This now can only be done when this is why do I do false there? It should be true. What? Oh, this one says false because yeah, I was confused. I hope I used true everywhere else just a second ago. Gonna do a lot of undos just to check that. Well, undo. Redo. True. Okay. Yeah, that's what I want. And then here we have false. Product E2. Oh no, the same problem again. E2 is not a constant or something, so we're going to have to duplicate this one as well. And I'm going to demand that it is not a constant, which then means that it's like the power is always less than, yeah, it's automatically okay, isn't it? Yup. And then this case is well, in this case it is a constant, so then that must hold using false value. No, I'm treating the value as a boolean, but it isn't a boolean. Oh, I have to, well, we'll see in a second. Anyway, so this is then like that. And then we have a power and a product, and this must be a constant, and this must be true. And then again change e2 into again the int of the numerator and the int of the denominator. Now what do I have? Apart from that I'm again changing e3 to, I don't know why, but I just want to be consistent, I guess. And I was looking for product still, wasn't I? Yes. And then we get a shitload of, oh my god, no, don't tell me. Really? That many? It just keeps on going, man. And this one conveniently doesn't say anything about E1. How did my test suit not catch that? What? This product's always less than anything that isn't a constant simple power of product. Yeah, actually it is true, because even if this is a constant, and this is still product level. So it doesn't get bigger by ignoring the constant. Yeah. Now this is a different story. Is constant E1 and is less. So this is again an attempt to yeah, so before I just added a constant in here, but might as well do that. I think I did that for multiplication as well here and there. So here it is a constant, and we're ignoring it, which means that this must be passing true. Compare constant equal. Yeah, it must still be true. We don't have this, and this must be using false. And here we do the same thing with a power. So that's going to be almost the same thing. We don't have this. We're using common false value there. And this must be true. Still, and A1 is a constant. Okay, is a product, yeah. And now all hell breaks loose. Compare product with a product. Yeah. Well, I guess if E1 or E3 is a constant, then I can combine them, because then we are skipping a constant. So that would be this case, where E3 is a constant, and here E1 is a constant, yeah, both are a constant. But this thing here is different. What if I just duplicate this? And then not this constant E1 and not the constant E3, and is less E1 than E3, or is not less E3 E1 and is less E2 E4. Okay, and in this case it seems to me that this must be still true. Because now I'm skipping a constant, even though I'm not sure which one. And then all of the is less sums must be changed. Is that true? I think so. No. It's a lot of them. Shall I try to do it fancy in the fancy way? Substitute is less sum v something. This is always e something. Always e. Always e even. E. And then some number. Well, any number then. 10 digits. And then followed by a comma, and then followed by an e again, and then followed by another digit, and then I only changed something on one line. What? Oh, there's a product there. Yeah. This product is constant. Yeah, that was not good. The E is not good. E is not good anywhere. Actually, let's remove the E. Just put here A to Z and A to Z. That should give me the product. Life is not that easy. You want to keep the product, you have to do something like what? Nothing is highlighted anymore. Shit. What the hell? Oh, could have used a star here. Where the fools are back. Still don't have my product though. So that's probably because these things are missing, I would say. That I turned into a foo. And that didn't do anything. Because I already have them. But I have all of them. No, there's a comma here. Comma is totally wrong. Maybe we should gobble up commas as well here. Nope. Damn it. Commas and spaces. Yeah, but that eats up too much. Or not enough. No, this is the latter one. I think it would have been faster by now if I had done this by hand. Maybe I'll do that. This is scary. Let's not do this. Well, I can do. I'm gonna do it by hand. I'm just gonna do all of it by hand. It's only a few things. Hopefully I did it right. I think so. I think so. So here's another product. E1 is a constant and there's less some So this is definitely skipping a constant here. Yeah. Next. That was everything. So now there's only one thing left, that is the multiplication. The double multiplication, which is here. And this one says E1 and E3 not as a constant E3. Ta-da, okay, that's cool. And I need one more duplication for the case where E1 is or isn't a constant. What is these two difference between these two? So let's just of course duplicate it. And then make the first one say that it is definitely not a constant. And then I don't have an or. Let's jump here. Remove the or, remove everything that comes after it. And then see that this one is me. Nobody understands it anymore. And I think I don't need these. This is just and. So not is a constant E3 or E1, and not is a constant E1 or E3. And is less some E1, E3 or not less some E3, E1 and is less some E2, E4. Totally agree. And in this case, we want to delete this one. Keep the E1 as a constant. Something like that. Let's see how this looks like. Not is a constant, and is a constant, and not is a constant E3. I already had that. That's strange. And less than blah 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 blah. Okay, let's see. 2 is less than that. Yeah, I agree with that. Okay, let's swap these two as well then. For no apparent reason. And then this one must be gone. And this must become, yeah, true. And this one must become false. No, that was all, I think. Thank God we have a test suit. I'm so going to bed if now we get 1 billion errors. Oh yeah, that thing. Atomic constraint must be type of bool. Do I still want to keep them or do I not want to keep them? Let's keep them for now. So everywhere I have this value must do unequal 0 because it's an int instead of a boolean. It's all the changes that I just made. Which are probably quite a few. So we're looking for a requires line that contains a value that is probably not followed by a space. Unequal 0. Unequal 0. Unequal 0. Unequal 0. Or unequal 0. Unequal 0. And then hope for the best. This could be the best, we don't know yet. The static assertion failed due to requirement blah 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 expected the same non-constant type. Oh really? That is the last one, but I made so many changes that by now I just want to see that it still compiles, or at least this one still compiles. Oh, what do we get now? Oh, it's still, I missed this one. I just missed one. There's a space after that one, yeah. That one. The one with the many values. And this is not followed by a space, and somehow I missed it. What the hell? More of those. What? What happened? I'll never know. Did I forget to save this file or something? So strange. I was looking for this. Dude, it doesn't exist. Requires. Oh, there's no requires on this line because it's requires many lines. Okay, let's just look for a value followed by not a space. Yep, now we had everything. Hey, it compiled. But not completely. Does it? Oh, everything is turned on. We don't have an. Oh, I have that, but what? Sorry. This very much looks like when it's turned off. Okay, let's turn it on like that. Hey, compile, compile. Yes, it compiles. Very good, very good. No run, no errors. Oh, this is an error, but it's an error about. Expected symbolic product constant to be less than. I'll never understand this. Substitute symbolic. Nothing. Expected product 3 times a symbol to be less than the product of a constant type times the power of a symbol. So this constant is ignored, then we get just symbol. And this constant is ignored, then we get just the power. Some symbol to the power 2. And yes, a symbol, certainly symbol 10. Actually, it should be compared by base. No, not for the sum, sorry. So this is, the symbol is just always less than the power. Yeah, I broke something. So product constant symbol to be less than the product constant power. Now surely symbol compares less than power. Do I really have to test this? No enter this. There's no into it. It's just never going to end. Never. Unlikely that we get here. Damn it, man. Proc it using arc1 is. Let's reproduce it. That type using arc2 less than that type. Dubious. Arc1 should be compared less than the other one. Why? Because the symbol is less than a power, period. And it says expected it to be less. Yes, because I told it so, but it doesn't. And now the first question is that because it failed to compare did it fail to, I mean, if you just ignore the constant, you get a symbol. That's, I expected to compare that with, well, also here we can ignore the product. If these two already don't work, then it had nothing to do with the product, but it does. I think this worked. Yep, that worked. So the problem really is related to the fact that we had a product here, and I deleted the other line, which is annoying, but I still have this line, so... Okay, reproduce this one. Okay, so power. And then here we had that one. The problem lays in the fact that we have two products with both have a constant. What if just one of them had a constant? So if I duplicate this one again, comment that out again and delete it again. What am I doing? Such a waste of time. So there would be one case. That fails as well, interesting enough. Might as well fix this one then. But let's first check the other case where I'm going to use this and then remove the product of the constant here. Pum, pum. Also not. God, nothing works anymore. Well, which is the easiest one? I think this one's pretty easy. So now I'm comparing a product of a constant times a symbol with a power. I can remember that still. No, I've got it again. It's not funny. Okay, product of a constant with a symbol with a power. Product power. Product constant with a power. Product with a power. Well, this could be anything, however, it's not a power. So this one's not used. There's a product with a symbol, definitely also not. Comparing a product with a power. There's a product with a power. Yeah, that would definitely match. But E1 must be E1 it must be a constant. So this is the one that should fit then, isn't it? It seems to me that this is the one. E1 is not a constant, so that's not the one. If we're going to look for other ones, line 135. Why the hell does this thing still exist? Oh, wait a minute. Yeah, that one. Yeah, that is with a product, not with a power. These are all of them. This is the one that should have been matching. E1 is a constant. E2 is a symbol with the power of a symbol. This is the only thing allowed first power and an exponent. So the only way that this, the only reason that this would not have been matched is because we're not using true, but I'm definitely using true. And then it could fail because this fails. Yeah, could be. It just could be. Let's test that first, maybe then. So I could test if this is true. Otherwise, it would never be used in the first place. Where E2 is the symbol, I think. E2 is this one, right? And the power is a symbol of ID 11 with exponent, this exponent. Comma false, values on equal 0. Compose. So that is true. Now compare less is using wait a minute. No. Why am I using false here? See, that's not correct. That is the problem. As you not get here. No, this is this whole thing is only going to be equal if constants are compared equal. Why? Because there's not a constant here as well. It's actually different when I add that one back, because then we have 2 times the same constant. But that's a good one. The constant is the same. I should not be skipping it. Oh, really? Oh, I did something wrong. But okay, yeah, that's why the other one, that's why this fails. But right now we are here, where just one of them is a constant. And then it doesn't really fail. I just have to tell it that I don't care about the value of constants. So, well, what does that mean? That means that I need to pass not either way, but constants compare equal. This test is only true when constants compare equal. Yes. However, if now I go back to the original problem, it's still failing. I think. It's not failing anymore. What the hell? Well, that makes sense actually. It's still treating. Okay, it doesn't matter if it. No, okay, yeah, nah. I don't know, man. There must be now. It's comparing two products where the first one is a constant. Constants, however, are no longer treated equal. Or however, the constants are equal. So in the end, I should be comparing this with this, and therefore it's less. But then how does it work? Because I thought that I just completely disabled the whole specialization for this compare. As if constants are always unequal, basically, which is not true, of course. And I thought that would be a problem. Yes, that is. If this is a constant, say compare product with power, then if this is a constant, then sorry, that's not true. Now we are comparing two products, of course. Otherwise, it wouldn't. This shouldn't indeed not be considered. Yeah, that is actually correct. But in the case of two products, the product is still going to work because. Or not, let me see, it's not constant. One of them is allowed to be a constant. Sorry, this one is also true. I need to have the other one. Two products, this one. This takes anything, but here both E1 and E3 are not allowed to be constants, which is bullshit. Because they are allowed to be constants as long as they are equal. Did something wrong here. What a bullshit. No idea what is happening here, but this should not be here. It's not a constant. Yeah, what? And then this comparison also makes no sense whatsoever. It's just something. Oh, wait a minute, it belongs to this part. Okay. So they're not constant. What? Did I lose internet? No. YouTube is also an idiot. I've got to delete this line. This whole thing should only be dealing with when we skip a constant. So either E1 or E3 must be a constant. So here's E3 a constant, here's E1 a constant, or both. And then the problem is that if we are already having this false, so this is not considered anymore, then, and this is not considered, just I'll call it again. I don't know if this works. I think I should really not compile. Why? I don't get it. I'm saying constants compare equal. Oh yeah, I say constant compare equal. This is not what I wanted to test. I'm an idiot. If I say constants do not compare equal, which is a thing because my search finds it. No, does not find it. Not equal. If you say they constants compare not equal, then I want them to still compare equal when they are equal. This thing is less than that thing because symbol is less than that, which means it must dive into this product. And I think that at the moment I use not equal, it's going to compare them equal because the whole product comparer doesn't exist anymore. It thinks that every constant is wrong, so it's going to return false when you compare these two. But it's, oh, two constants compared, no, that's not equal, basically. So I think that in this case it does compile, but if I don't run it, it fails. Yep. And the problem here is that I don't have something that accepts E1 and E3 to be equal constants. Well, this is true. What about less constants? I kind of... what the fuck? Not a constant. I'm not talking about true. If this is true, let me get here. Here I don't have the... Here I don't allow them to be compared because I don't allow them to be constant at all. That is maybe not correct. That is only not correct if this is false or... Man, I'm stupid, I think, because I don't get it. I think I should go to bed. Tomorrow I'll wake up and I just sit behind my PC and fix it in 10 minutes. Probably. Probably. So, yeah, I think I'm gonna call it a day. Stupid thing is I don't feel tired. Last I lost a game with chess, while they use me as a, what is it, a sure point in our team. I didn't lose anything yet externally. It's not because I'm a world champion, but because I'm playing in a low class, so I get easy opponents. Nevertheless, I did lose, and it was because I didn't see a mate in one. Seriously. A really, really horrible game. I had to play against an 11-year-old or something like that. And then you start to be scared. Those kids usually can calculate like crazy. So I managed to get a completely winning game strategically because he had a horrible bishop. Like, I did exchange everything, so in the end we only had both a bishop and a rook. And his bishop was on the white squares, and he had like 7 pawns on white squares. Really, it was, yeah, come on. Now later I put it in a computer, and it was a draw, so I didn't win. He could keep it close somehow, some reason. I don't know what, well, okay. But still I should have kept it a draw. But while playing, I thought, if I do this, I get inside the position. I was moving with my king forward. And I'm just going to win, because there's no way you can defend this. And that was completely correct. I was like +4. So I was completely winning with my move. Except for one minor detail. He could move a pawn forward, giving mate. And I had missed that. So I had a strategically winning move, and I did it, and didn't see that it was not possible, because I just couldn't go there. It was mate. And now I think maybe I had the same thing as I have now while coding. I don't feel tired. I just somehow know that if I go to bed and I wake up, then it will be easy again, and I will just fix it within no time. So somehow my brain must not be working anymore, because it's the end of the day and I've already been coding for many hours. There's some YouTube puts stuff over it. Okay, it says, what makes you be this much concentrated for that long? I don't know what the body does there, but yeah, well, I trained myself in that my whole life. I've always been very concentrated on whatever I'm doing. It might be an autistic trait, or people with autism tend to be able to be very focused on what they're doing. It's kind of the opposite of ADHD. If I concentrate on something, then I'm just completely into it. Okay, I was musing about the possibility that my brain is working a lot less efficient or good or at all, while not feeling tired. I have a little story about that. So when I was a teenager, so for those who don't know, I'm 59. I used to be a genius. I don't think I'm now, because I'm just feeling stupid like hell and I can't do things anymore. When I was a teenager, I was already thinking every day, all day. And if I thought long and hard enough, then I literally use my ears as cooling ribs. What is the word in English? I don't know. Cool fins. At least AI is useful for that. That's the heat sink, yeah, okay. So I was, yeah, that is the word. I was using my ears as a heat sink. They would become really hot, red and hot. And that was definitely needed to cool my brain. I think feeling my ears now, that is cool. It's completely cool. So I haven't been thinking at all during these 3 hours, I think. Not like I used to. Yeah, I don't think I ever had a moment in my life where I didn't think deep. My memory is pretty bad. I can't remember much of my youth. But I do remember here and there, let's say, stories or anecdotes about particularly brilliant moments that I did certain things. And the earliest such anecdote that I still remember, because I told it more often, I guess, that around when I was 7, that I said earlier, so yes. When I was 7, my dad was a programmer as well, and well, computers didn't even exist back then, did they? So he was in electronics also. I'm doing also electronics, or did. So he would give me resistor networks, and then I just kept asking him for that, and then I would have to calculate the final resistor. Can you get an image of that? Resistor network. Oh, okay, something like that. Something like this. That would be a nice example. So this is actually too simple then, or at least at some point it was too simple. But that's the thing that I like to do. So he would give me a network like this with values, and then I would calculate the total the total resistance. And then the next day I would say, I want one that's more complicated, bigger. Yeah, I really enjoyed it. Maybe something like this. Oh, gets bigger, yeah. That's not complicated. But again, enough about my youth. I'm just going to bed. Good night. I don't have to be a genius to motivate people, but yeah, I'm happy that that is the case. Keo codes. Of course, Keo codes. Yes. Maybe I'll watch your coding someday. Maybe I should. If I watch my own videos back, then I really can't get to it. Last, I had to watch my own video back because I wanted to find a certain spot, and then it's hardly bearable at speed 2. And then even then, I'm just like, man, come on, all those pauses. I really can't imagine that anyone. Well, I can see that. I can see that. Your average view duration 9 minutes, which is ridiculously high. In the beginning, it used to be like 1 minute or 2 minutes, and I think that I get now an average duration of 9 minutes because a few people just sign in from the beginning and they don't. They just let it run for 3 hours, so I get a pretty high average duration. Most people just come here and then immediately leave again, I suppose. And then those that stay 3 hours, they don't watch me. Come on, they're working themselves with me in the background. That's how I see it, or I understand it. Which is completely understandable because if you actually watch my videos, it's just way too slow. At least if I watch myself back, it's no. If I would make videos about C++ that are to teach people to actually learn something or to for entertainment or whatever, that would be so different from this. So different. Then I would have something prepared and it would be exciting to follow. And not just me staring at the screen with compiler errors and pausing 5 minutes at a time because I'm thinking.